All right, let's talk about domain and range. Domain is just the set of all the possible input values, so all the input values that are valid. And the range is just the set of all of the possible output values. All right, so let's take a look at this next example here, example 4. We're asked to actually find the domain and range for the functions. All right, so the first function is just y equals x squared, and it's graphed here. And when you have a graph, it's pretty easy to find the domain and range for the most part, right? So now that we know this is y equals x squared, so we're looking for, when we're asked to find the domain, we're just looking for all the possible input values. All right. So now from the graph, you only get a portion of the function, right? You can't graph to infinity. So you're always just going to see a portion of the function. But knowing that y is equal to x squared is our function, then are there any x values that are off limits, right, that we can't put in and square it and get a number? And no, you can square any number from negative infinity to positive infinity, right? Um, so so the domain is really all real numbers, or we can write the domain as negative infinity, um, less than x, less than infinity. So this just means x is between positive and negative infinity. So it's any number for x is valid. All right, but then let's look at the output. All right, now can we ever get a negative output if we square a function? If we square a number, can we ever get a negative number? From the graph, it looks like there are no values below 0, right? So when you square a number, you're always going to get something positive. So our y values are always greater than or equal to 0. Now I want to include 0 because this point right here is part of the graph. That's point 0, 0, right? When x is 0, y is 0. So 0 is um, a valid input, or valid output of the function. All right, so we're going to include that. So that's it. We're just going to, at least here, we're just going to use inequality notation. I'm going to give you a handout on something called interval notation. That's just another way of expressing a set of numbers. And but right now we're just going to use inequality notation to give the domain and range. All right. This next function is y equals x cubed. All right. So it's graphed here, or at least you can see a portion of the graph. And so again, what's the domain of the function? That's just all the possible input values, all the possible x values. So are there any that are off limits? Is there any number that I can't cube? If you give me a number, I can cube it, right? It doesn't matter what it is, I can cube it. If it's 1 or 2 or -5 or negative 5,672, whatever, I can cube it. And so the domain is again from negative infinity to infinity. Now notice I just use less than signs here, not less than or equal to signs, because we can never actually get to infinity. Infinity is not an actual number. So we can never actually go there. All right, what's the range of this function? So this is the set of all possible output values. All right, now it's a little difficult to tell from the graph, but you can see if x is positive, it's just growing bigger and bigger and bigger in the positive direction, and when x is negative, it just gets more and more and more negative. All right, so are there any output values that are not possible? If I gave you an output, could you calculate the input? Yes, I mean you're right. There's no there's no output values that I can't get. Um, so the domain is also from negative infinity to infinity. All right, it just goes as far positive as you want, as far negative as you want. All right, now all of these 4 functions that we're going to look at in this example are considered to be parent functions. So parent functions. And we're going to see how we can use these functions later on. So if we know the properties of these parent functions, then we can find properties of functions that are based off of these parent functions. So, so these are important ones to understand. Now, this domain and range will hold for any even power of x, right? If it's just x to some power, as long as it's even, it'll have the same domain and range. So sometimes these are called, this is called an even function. Even function. Okay. All right, it's just an even because it's an even power function, and it has a certain symmetry to it too, right? It's symmetric about the y-axis. We're going to talk more about that later on too. This is an odd function, right? This is the odd function, and it's going to have any odd power of x is going to have the same domain and range, and it also has a certain symmetry to it as well, right? So we'll talk more about that later. All right, let's look at the last two here. We have the square root function and we have 1 over x. All right, these again are parent functions. So, let's try and understand the domain and range of the square root of x. All right, so we have the whole thing graphed, right? We can never put in a negative number, right? And get a real solution. So, the domain does not include negative numbers. It does include 0. So I can say the domain is x is greater than or equal to 0. And the range, now the square root is always defined to be positive, right? So so the output is always positive as well. Now it can equal 0, so I'm going to include 0. So y is greater than or equal to 0. All right, so that's the domain and range of the square root function. You can never put in a negative number and you can never get out a negative number. All right. And then finally, the 1 over x function. Now I have it graphed here. Let's look at the domain. Are there any values of x that would be off limits? So for 1 over x, I cannot divide by 0, right? So I'm going to say that the domain is x is not equal to 0. Anything else is fine, right? Except for 0. All right, because I can never divide by 0. Now you can see what's happening at 0. As I divide by smaller and smaller positive numbers, it's growing bigger and bigger and bigger, right? Because if you divide something by 1/2, right, that just means you're creating groups of 1/2, right? So I'll have 2 groups of 1/2 if I divide 1 into groups of 1/2, right? So divide by 1/3, I get 3 because you're dividing 1 into groups of 1/3, right? So you get 3 groups of 1/3 makes 1, right? So if you divide by 1/1,000,000th, right? That means that you're creating groups of 1/1,000,000th, and so you're going to end up with 1,000,000 groups of 1/1,000,000th if you divide 1 by 1/1,000,000th. All right, and then for negative values, as you get closer and closer to 0, you can get as close to 0 as you want. You just can't actually go to 0. All right, let's look at the y values, right? We want to look at the range, which is all the possible output values. And you can see again, we have this issue happening at 0. We can never divide 1 by anything and get 0. Now, it gets smaller and smaller as you divide by bigger and bigger positive numbers. Divide 1 cookie among 1,000,000 people. That's going to be a little teeny bit of a cookie. But it's not 0, right? So y just cannot be equal to 0. All right, and so all right, so that's how we can express the domain and range. So basically, this is implying that it's good for all real numbers except 0. Now, again, like I said, we're going to learn interval notation as well, and I'll give that to you in class. All right, I will meet you in the next video.